Okay, the last area that I have for Reteach is inverse relations. And so these are our notes on that. And when you think of an inverse, what you're really doing is if I'm looking at, well, let's go, an inverse relation is a reflection over the line y equals x. And if you think about that, that's this line right here. Okay? And so if I look at the point 3, 4, if I'm going to reflect it, it will be right here. And that's at the point 4, 3. And so what ends up happening is our y becomes our x and our x becomes our y. And so if I had the point 1, 1, because it's on the line that we're reflecting, its inverse is itself, is 1, 1, okay? Now, if I want to do an inverse, or if I want to do a reflection over the y equals x axis, which is, again, right here, I want to look at the inverse of a problem. All I have to do is plot the points. So this is negative 3, 3. This is negative 1, 3. This is 0, 4. 1, 4. And 3, 6. Okay? All I have to do is take these points and flip them. So if I look at 3, negative 3, that will be my first point. Then I'll go to negative 1. No, I'll go to 3, negative 1. That's my second point. So I'll move up. Then I'll go to 4, 0. And then 4, 1. And finally 6, 3. And now I have a perfect inverse of the initial graph. If this was f of x down here, then our inverse, f of x, the inverse is written like this, f negative 1 of x, and that's the f inverse, the function inverse of x. So this is f negative 1 of x. Okay? Now, graphs are one thing. The problem is most of our equations are not written as a graph. So if we have f of x equals 3x plus 2, if we want to find f inverse of x, what we have to do is I'll take this equation, I'll change f of x to y. So that's our first step. I just have y equals 3x plus 2. Now our next step, and I'm going to do this in a different color, is I'm going to change my y to an x, and I'm going to change my x to a y. And that's my inverse. But the problem is I have to solve for y. So to do that, I'm going to subtract 2 from both sides. And so I have x minus 2 equals 3y. Now I'm going to divide both sides by 3. And when I divide, I have to divide everything by 3. Okay? So now I have y equals x minus 2 over 3. Well, if I want to change the way that's written, if I want to make it in the slope-intercept form, I can put 3 under both of these. I have a single denominator. So that's like x over 3 minus 2 over 3, which is the same as 1/3 times x minus 2/3. And so my inverse function here is 1/3 x minus 2/3. So if this had been my original function, this would have been my inverse. This being my original function, this becomes my inverse. This would show you one way that you can actually use this is I can take this, find its inverse, which will be that, and I can graph that much easier than I can this. Okay. Let's do some others. I want to do some that are a little bit more challenging than that. Move this in a little bit. If I take f of x equals x squared plus 4, and I want to look at what is the inverse of f of x.